So, yesterday we discussed the gate in extreme detail. Uh, Not and or nan nor x or. You can go through these. We also discussed the logic circuit of an or XOR gate and how they can ask you to create it and how you should create it. Let's look at logic circuits today. Today we're gonna devote the next hour and a half to Boolean logic. All right, let's do. Okay, so logic circuits. Now, logic gates mainly they took in two inputs and calculated an output, right? Now, logic circuits they're a combination of these different logic gates to manipulate the bits to your own preference, right? So, in computer science, they have a lot of uses like addition, triple carry addition, and all of that. Okay, and let's just see the smallest logic circuit that we can create. Okay, so let me just bring out my drawing tool. Let's draw A and B. Let's just say I want to get the OR of A and B and the OR of A and B twice. So I'll add another one right over here and one right over here, and I'll add two OR gates, and then I want to combine them with an AND gate. Alright, please excuse my incredibly bad drawing, but this is basically what that logic circuit will look like. Now, the zeros and the ones they travel along these wires when before they go into the gate. So there's a zero that goes here, blah blah blah, 0 1. All of that travels through these wires, and you place gates for the zeros and ones to go through. Now, if we look at this circuit, we can see that firstly there is A or B. All right, so let's just write this down. We learned yesterday that the Boolean algebra for an OR gate is plus, and for an AND gate it's dot, and for a NOT gate it's a dash right up above the letter. I can't really draw that out here. Alright, so let's just write the Boolean algebra for this gate. Okay, so let's start. Firstly, you want to notice A and B, they both go into an OR gate. You see, B wire goes into this OR gate, A wire goes into this OR gate, so we can just write A plus B. Right now, what we've done is we've created this part of the circuit. Right, we created this part of the circuit. Now let's move on to the other part. Okay, so the second part, the second gate is also A plus B. All right, we just created this part of the circuit. Now, to prevent confusion, what we can do is we can group these or add parentheses to it. So A plus B bracket, and same here. Now, what we've done is we've written this part of this logic circuit. Now, we just have to add an AND gate to calculate the X. All right, and let's just add a dot here because that's what we discussed is the Boolean algebra for a AND gate. So now we have this part of a logic circuit in Boolean algebra. But this is wrong. Why is it wrong? Because we forgot to write X is equal to, okay? We have to say that X is equal to A plus B and A plus B, right? So that's how you construct a logical circuit for this. Let's try another one. Okay, let's try another one. Let's do A, B, A becomes not A. All right, this is a NOT gate, and this goes into an AND gate. B comes here, and this one, this B wire also goes here. This B wire also goes here. Right now, we're just learning how to write Boolean algebra of these gates. This is also an AND. This goes here, and this goes into an XOR gate. Now, listen. Boolean algebra and logic expression, they're very different, okay? Now, logical expressions, they're just the names of the gate. Let's see how they look like, okay? So, Let's just write the Boolean algebra for this part once, because we haven't learned anything about the XOR gates Boolean algebra. Let's just write this part right over here, okay? So that would be A naught, right? Let's just add the dash. So what I've done so far is I've written down this part of the circuit, okay? So A naught, and then you wanna add an AND gate, A naught, A naught, and B, all right? And you can of course group this. So now you have A naught, not A, and B. Okay, I'll just erase this dash, bring it to a better place. So you have not A and B. So right now what we've done is we've created this part of the logic gate. Okay, now let's work on the second part, which is going to be, let's see. So A is taken before the not. So it will be just A, and this is an AND gate. So A dot, and you got B going in there. So let's group this as well. And yeah, that is this part of the circuit. But let's just say they want us to draw a logical expression. How does that work? In there, you don't need to use these fancy symbols like plus, dot, or a dash. You can just write the names of the gate. So, for instance, not A. What is this? This is the logical expression for just this part. Okay, let's write it further. And B. What is this? This is the logical expression for this part and this part. So this whole thing, this is written as not A and B. All right, and let's group this because grouping is of course required. And let's go over here. Let's write this part now. So it is going to be A and B because there is no NOT gate between this part. Okay, so we just wrote it as A and B. Let's group that. And now what we're gonna do is we are going to write the XOR gate, which is just XOR. So we're just gonna write XOR in between, and never forget to add the X is equal to. Okay, always add the X is equal to if they ask you to write a logical expression, especially if it's 3 marks or something like that. So this right over here, this is the logical expression for this part. Now, if you ever have trouble doing this, I suggest you to follow this strategy. Okay, let's just say that you have your examination tomorrow and you have this logic gate in front of you. The best part to do it is grab your pencil, all right, and highlight this part, and then highlight this part, then highlight this part. All right, go through each of the gates once. So how would that look like? First, you will make this part. So that would be not A. Then you would work on this part. That will be not A, which is this thing, and B. All right. Then you would work on this part, which is going to be A and B. Okay. And now you're gonna combine these two together by adding an XOR gate, and you will group them to get the final answer, which is going to be not A and B grouped XOR XOR A and B. All right. But that's a strategy if you don't understand. If you know how to read a logical circuit, then it's going to be insanely easy. So let's do a harder logical circuit. Let's do this one with 3 values. All right. And okay. Let's select this. And let's bring it over to here and bring it on top. All right. Let's insert the truth table as well. So I'll just insert a 10 into 8 table and I'll bring it down a bit. So they're going to tell you AX, A, B, and C. They're going to give you A, B, and C. They're going to give you working space and then X. Let's assign letters once again. So what we're going to do is I'm going to assign C to this wire, to the output of this gate, D to this one, E to this one, F to this one, and I'll assign G to this one, E to this one, and X already is that last one. All right. So now let's get to solving. Let's solve with the easiest ones first, which are the NOT gates. Now, when you're solving it through into a truth table, as long as you fully plotted out the letters, you can chill out. All right. You don't need to do anything else. So C, D. Sorry. I realized I messed up. There can't be a C. I messed up. I'll just change this T to a, so E, F, G, H. I'll change this to an H, okay? So you got H, D, E, F, G. All right, let's solve H first. So H, sorry, I'll write the values down as well. 0, 0, 0, 0, 1, 1, 1, 1. For B, you will have 0, 0, 1, 1, 0, 0, 1, 1. For C, you will have 0, 1, 0, 1, 0, 1, 0, 1. For H, let's calculate H. So H is the not of A. Whatever bit you have in A, it's going to be the opposite of that. So 1, 1, 1, 1, 0, 0, 0, 0. Right? Now D is the not of B. So whatever you have in B, it's going to be the opposite of that. So 1, 1, 0, 0, 1, 1, 0, 0. All right, then give me a second. Let's resume. Okay, so now let's look at E. E is the AND. So you can see the AND gate right over here with this output to E. AND of H and D. So these two values. And the AND of these two values is going to be E. So let's look at it. So 1 times 1, 1, 1. And then the rest are going to be 0 because look, there's a 0 here. There's a 0 here. There's a 0 here. And then so on. So 0, 0, 0, 0, and 0. Alright, now let's look at the next one, which is the F. Alright, now F is the XOR of E and G. But we haven't calculated G yet. Alright, we haven't calculated G yet, so let's do G first. Alright, so G is the OR, so you can see the OR gate right over here. It's the OR of A or B. Okay, so you got A or B, which is going to be G. Alright, so let's just do this again. So A, 0, 0, that becomes 0. 0, 0, that becomes 0 again. Then it's going to be 1 for the rest of them because they all have 1s after that. Okay? Then let's look at F again. XOR of E and G. E and G, the XOR of these. So I'm just going to bring F further as to avoid any confusion. Alright, so I'm just going to bring it further. Yeah, okay. So F is going to be the XOR of G and E. Okay, I'll just bring this back actually. I just realized the mistake that I did that I'm going to explain later. But okay, so 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 1, and put F here. Remove these. Alright, so the part about XOR gate that we've learned is the statement if same, then false. Alright, or if different, then true. Alright, simple statement. Alright, if same, then false. So let's look at E and G. E and G, which go into this XOR gate. If it's the same, then it's going to be false. If it's different, then it's going to be true. And you can already see that all of these are different. Right? So there's no 0, 0 or no 1, 1 here. Alright, so we're just going to write 1 for all of them. Alright? Because they're all different. So 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. No one of these bits match. Alright? And now, lastly, let's do this one, which is, I believe, I. I'll just rename this as I, which is the not of C. Alright? The not of C. I, which is the not of C. And that is going to be 1, 0, 1, 0, 1, 0, 1, 0. Alright? So this 0 becomes a 1, this 1 becomes a 0, and then so on. Alright? Now, I forgot to assign a letter right over here, so I'll just assign it the letter J. Alright? And we're gonna write J here instead of X for now because I've run out of table space, but J. Alright, so J is the OR of F or I. Alright, so these two, we're gonna add them. If there's a 1, then, well, the whole value, the end value is gonna be a 1 as well. And you can already see that F already has all of 1, so let's just do this. There's gonna be 1, 1, 1, 1, 1, 1, 1. Alright, because F already has 1, so adding a 0 to it won't change anything. Alright, so you have J. Now let's move on to X. Alright, so then I've run out of space, so I'm just gonna insert another table here for X, just down here. Alright, so okay, so X, it is going to, wait, I think I messed up. Let's re-insert the table. Okay, so X is going to be the AND, this is an AND gate of J and C originally. So this and this is going to be an AND gate. So let's just do this real quick. 0 times 1, that is going to be 0. All right? And then let's look at the second one. 1 times 1, that is 1. Okay? So if there's a 0, it's the whole value is going to be a 0. And we already know that J's is all 1. So let's just look at this one. So 0, okay. So 0 times 1, 0. 1 times 1, 1. All right? And it's going to go on like this. So it's going to be 0, 1, 0, 1. Okay? Because 0 multiplied by 1 is equal to, well, 0. Okay? So your final answer to this logical circuit is going to be 0, 1, 0, 1, 0, 1, 0, 1. All right. So there's all sorts of logical circuits that you can create. All right, and all sorts of ways that you can solve them. Instead of writing instead of writing HD, I could have just wrote like something like I could have wrote something like A and then added a dash on it to signify that it's a not. Same goes for D. I could have just said that it's B not. All right, and for C, I could have said something like for E, I could have said something like H and dot H A dot B. I would have grouped it, and this is how I attempted my CAIE paper as well. So please don't call me a psychopath. But yeah, you can do it this way as well, or you can just assign letters to it, whichever one you find easier. Now let's take another break before we come back and solve logical circuits through logical expressions. Okay, let's move on to solving logical gates with the logical circuits with the help of just logical expressions. Okay. All right. Oops, my bad. Okay, let's write a random logical expression. Okay. A and B and C, or A and C, or B XOR C. All right, I'm gonna make this insanely long because we've already covered the short ones above, and yeah, let's do this. Okay, so two ways to approach this. Let's start with the fastest way, right? You assign letters to each statements just like you did with the logical circuits, except this time you assign them with the statement itself. So get a pencil and just like mark this as D, mark this as E, mark this as F, mark this as G, mark this as E, and overall you want to mark this whole thing. This whole thing is already marked as X. All right, so you can solve it this way. Let's create the truth table for this. All right, so I'm gonna insert a table. Let me just bring it back. And okay, so let's insert the table. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I'm just gonna insert a 9 into 8 table and bring it down by 1. So let's just write the values. Okay, so A, B, C, and X. This will already be written. The values of A, B, and C will be given to you, and if not, I'll teach the technique at the end again. And then you got 1, 1, 0, 0, 1, 1. Then you have 0, 1, 0, 1, 0, 1, 0, 1. All right, and this is gonna be your working space, but I'll just write all the letters here: D, E, F, G, and H. All right, this is supposed to be an H. Please ignore the trash drawings. All right, let's do D. So we know that it is A and B. So multiply them. So you got 0, 0, 0, 0, 0, 0, and 1 and 1. Okay, 0 times 0, 0, 0 times 0, 0, 0 times 1. So if there's a 0, the whole value is going to be a 0. Then you have E, which is D and C. So this and this multiplied. So 0, 0, 0, 0, 0, 0. And then 0 again before a 1 at the end, because this is all zeros and this is a 0, so that then this all becomes a 0. This one at the end becomes a 1. So you're done you're done with this part of the statement. All right, you're done with this part of the statement. Let's move on to the second part. A and C, which is F. Okay, so let's do this. A and C. So first four already becomes zeros. You can just see by this. All right, so 0, 0, 0, 0. And then let's move on to the second one. So there's a 0 right over there. So the whole thing becomes a 0. Then you can see that these are both 1. So that becomes a 1. Then you see a 0 again. So that becomes a 0. And then you see 1s again. So that becomes a 1. Right? Next up, you have G, which is just going to be the value that you calculated. F or B. All right, so F or B. So remember, if there's a 1, then the whole thing's going to be a 1, or you can just add them together. Okay, so F or B. So 0, 0 is going to be 0. 0, 0 again is going to be 0. Then you have two 1s because there's a 1s in B here. And then you have 0 again. And then you see 1 right over here. And then these both are 1 as well. So this is going to be the answer to G. All right, let's just reconfirm this. A and C. So that becomes 0, 0, 0, 0. And then you got 0, 0, sorry, 0, 1, 0, 1. All right, and then G is going to be the value that you calculated in F or B. So 0, 0, 1, 1, 0, 1, 1, 1. All right, let's do E now, which is going to be the value that you calculated in G XORed with the value of C. So remember, if same, then false. So this is same C and G, so we're gonna do 0. But then you got a different one, so 1, 1, and then you have 1 and 1 again. Alright, so that's gonna be a 0 again. Let's move on to the next one. So you see 0 and 0. That's gonna be a 0 again. And then you have 1 and 1 again, so that's gonna be a 0 again. And then you have different again, so that's gonna be a 1. And then lastly, you have a 1 and a 1, so that's gonna be a 0. Now you have H and you have E. Now, to get X, all you have to do is add them together because there's an OR gate in the center. So E and H. E or H. Alright, so you got E right here and you got H right here. E is all zeros except the last one, so I'm just going to write under. And so now we just can copy H. So 0, 1, 1, 0, 0, 0, 1. So this is the final answer for this logical expression. All right. Okay. So let me just tell you guys the second method to solve a logical expression before ending today's class and finishing logical Boolean logic tomorrow. All right. So let's look at the second method. Now the second method is similar to the ones that we solved before. You create a diagram. Now, how do you create a diagram? Firstly, analyze the amount of letters. So we can see an A, we can see a B, we can see a C, and nothing else. So what we're going to do is we're going to write A, B, and C. Now there's two ways to do this on the examination CAIE paper. You can make a small mini circuit next to the logical expression, or you can use the blank pages at the end. But remember, save some of them for the pseudocode planning question, which is the 15 marker, all right? But you can also use this places at the end. But remember to use it with a pencil just in case you need that space once again. Alright, so what you're going to do is you're going to follow a similar pattern to the letters. You're going to start at the left and then make your way. So A and B. Alright, so this one requires you to have knowledge on how to draw logical circuits, which can get a little bit complicated. Okay, so A and B. And then you're going to make and C. Alright, so this goes out and into another AND gate with C. Alright, and then we're gonna solve this part is done. Now we're gonna do this other part, which is A and C. So we're gonna write a dot here, small dot, to indicate that the wire is going out. And then same here, the wire is going out, and we're gonna AND it, and then we're gonna OR it with a B. So we're gonna create another dot here, bring that out. So this goes into an OR with B. And lastly, this value, this goes into an XOR with C. So I'm just gonna bring it, we're just gonna bring it from here into here, and then we're gonna output it with an OR, which is the final value from here, and this becomes X. Now this is way longer, but if you don't know how to use an expressions and use letters the first way, you can always utilize this way. Alright, and then you can solve it by diagram if you understand that method. But I don't recommend this one. I always recommend that you practice a lot so you can get better at this method. All right, and yeah, that marks an end to today's class. And if you like the classes, if this has been helpful, you can join the official server where I do these classes. That is going to be linked in the description as the r/IGCSE Discord server. All you have to do is go up here, right? You're gonna go to channels and roles, and you want to go to CAIE IGCSE, and you want to select May June 20 your year, and then in the IGCSE subject roles, just select computer science. All right, that should give you access to also this study session roles. You should select computer science here. That way, you will get pinged every time there's a computer science lecture, or if you want to take other subjects, they're also available here. All right, and yeah, I hope you guys enjoyed this, and yeah, see you guys later.